Alright, you should be working on problems 165 to 168 out of chapter 7 from your book. If you're watching this video, you should be using it as a way to help yourself if you get stuck on a problem, and I need all of you to use it to check your answers when you're done working on these problems, because I'm assuming that on Friday, when I come back, we can move on like you all know exactly what you're doing. So we're going to start with 165 and kind of go over part A, which is asking you to take matrix B, which we had from before, previous classwork, which had the two stores, Bullseye and J.C. Nichols, the cars and trucks, in the matrix. So that was what matrix B was before is what I have written down right now. And now it's asking you to add another row to that for Marcy's department store, which they're using 12 cars and 24 trucks. So I added that to the bottom of my matrix B. So this right here is matrix B. And then part B is saying to multiply that new matrix B with matrix A, which I wrote right there. And so there's a couple things that I want to mention. I'm going to kind of talk through part C as this is happening, and then we can kind of skip that at the end. But what you're going to notice is as I'm multiplying this, matrix B, that red one, is a 3 by 2, and the 3 rows represent the stores, and the 2 columns represent vehicles. I like to write it in numbers, the dimensions, and in labels, so that when I multiply, I can see what those labels represent at the end. I am multiplying that by the orange matrix, matrix A, which is a 2 row by 3 column, vehicle by part matrix. And it's talking about what, I'm going to find the product of those two matrices, and it wants me to state what that product represents. So we know that these 2's in the middle have to match in order for us to be able to multiply. The other thing I want you to notice is how I'm multiplying cars and trucks into cars and trucks. So I see how these 2 columns and these 2 rows both have the label of vehicle. That's important because when I'm multiplying matrices with each other, I have to use the same labels as my inside dimension, so vehicles and vehicles. And that should happen every time you set up a multiplication problem in a word problem, okay? And the other thing you're going to notice is we know already that we end up with a 3 by 3 matrix, and the labels go with that too. This matrix that's my product is going to be a store by parts matrix, and I'll show you exactly what I mean when we're done multiplying. But we're going to set up a 3 by 3, and the rows of that 3 by 3 are the stores, as in the first part of the red matrix, and then the columns are the parts, as in the last part of the orange matrix that I circled there. So this is going to be a 3 by 3 store by parts. So remember, when you're multiplying, you multiply rows into columns. So I circled the first row, I circled the first column, and what I'm going to be doing is 20 times 4 plus 25 times 6. And that's going to give me the total number of wheels that Bullseye needs to make their cars and trucks. Okay, so when I do that, I end up with 230. And then if I fill in the rest of the top row, I multiply 20 and 25 into the second column to get 65, which is the total number of seats. And then I multiply that first row into the third column to get 95, which is the total number of gas tanks for Bullseye. At this point, if you are just following along with me, pause the video and do the rest of this matrix multiplication to make sure you can. If you're just checking your answers, go ahead and let it keep playing. Otherwise, pause. And now you can check the rest of your 2 rows, and I'm going to play that now for you. So 240, 60, and 105 for J.C. Nichols, and 192, 48, and 84 for Marcy's. Now that 3 by 3 is telling me the number of parts that I need for each store. Okay? And I kind of talked already about how those labels and numbers have to relate, so that kind of answers question C. Alright, now moving on to question 166. This question is asking me, is talking about the cost that it costs Otto to make cars and trucks in his toy factory. And part A there, 166A, is saying use descriptive word labels to make a 1 by 2 matrix of these 2 pieces of information, the 275 per car and the 310 per truck. So if I'm going to make a 1 by 2, that's 1 row and 2 columns. You can see that I drew it in there in red. And that is a cost by vehicle matrix. Now, I'm not quite sure if that's how I should have it set up, or if I should have it set up as a 2 by 1 matrix. So part B is asking you to draw that same matrix information, but this time making it a 2 by 1 instead. So that's going to be the same thing, just oriented more up and down with 2 rows and 1 column. So this time I have a 2 by 1 and the rows represent the vehicles, whereas the column represents the cost. So it's a 2 by 1 vehicle by cost. Okay, now part C is saying that we need to multiply one of those two matrices, and we're going to call that matrix D, and we're going to multiply that with the expanded matrix B from the last problem. So take a second, flip back, and copy that matrix B down. And only one of these two matrices is going to work to multiply there. So the reason that they had you build both was to kind of develop an understanding of which one that you would actually want to multiply. So that matrix B, just as a reminder, is that 3 by 2 store by vehicle. Now, if you look at the red matrix from part A that we made, it doesn't matter if I put this matrix on the right or the left, the dimensions won't match up. And in fact, the vehicle labels that I need to match up won't either, because I need to have cars and trucks being multiplied into each other as the inside dimensions. So matrix A is out, and I'm using the one from part B. Okay? In order to make this multiplication possible, I have to put that matrix, which we're going to call it matrix D. I need to put that on the right side of matrix B, and I'm going to kind of multiply it in together. Noticing that the cars and trucks are on the top here and the rows here. And so those two dimensions not only have the same number, but they also have the same labels. Okay, so what that tells me is I'm going to have, when I'm all done, since I'm multiplying here, I'm going to have a 3 by 1 store by cost matrix. So when I'm all done multiplying here, I'm gonna know the cost that it costs to fill the order for each store. Okay, so go ahead and pause, do that multiplication, get yourself a 3 by 1 matrix, and play when you're ready. Alright, you did your multiplication, you ended up with a 3 by 1 store by cost matrix. And what you did was you multiplied 20 and 25 into that column to get your first number, and that gave me 132.50. And then I multiply the other two rows in as well to get the rest of the matrix, 134.25 for J.C. Nichols and $107.40 for Marcy's. You're going to see that I labeled this matrix here as the new E, and I labeled the one over here with a D. So keep those labeled nice and neat on your paper. This is E, this is D, okay? The last part of this problem, part E, is saying what does the entry in the third row first column of matrix E represent? So the third row first column, you have to count down to the third row. There's really only one column. And the number there is $107.40, and that entry right there represents the cost of the order for Marcy's, okay, the total cost of that order. So it really helps me to keep those labels going throughout the whole problem so I can kind of see what's going to happen. Alright, let's go on to 167 and check that out. 167 is talking about Otto's profit now. So we looked at the cost and now we're talking about the profit. It says that he is charging an 86% markup beyond his cost on the vehicle he sells to Bullseye, 74% on J.C. Nichols, and a 93% profit markup on Marcy's. So it says in part A, make a matrix to represent Otto's profit percentages, that's going to be your row, by store. So this is going to be one row, which represents profit, and then the 3 columns for the 3 different stores. And I'm going to go ahead and do that with those percentages, and I'm actually going to change those to decimal so I can multiply it out in part B. Okay, so that matrix looks like this. You've got the profit for Bullseye 0.86, JC 0.74, and Marcy 0.93. And then part B wants you to multiply that profit by store matrix with matrix E. So this right here is a 1 by 3, and if you remember, matrix E was a 3 by 1, so I have to put that one second. So I'm going to go ahead and write that in. And notice how this time the inside dimensions are those stores. So this is the stores, this is the stores. And so the 3 columns here and the 3 rows here that match up are all stores, and that's good. That's what I want. Okay, so I'm going to end up with just a 1 by 1, and that is going to represent the total profit that Otto makes from all of the stores in a week. So go ahead and pause, multiply it out. You're just going to get one number. 0.86 times 132.50 plus 0.74 times 134.25 plus 0.93 times 107.40. Go ahead and multiply that out. And you should end up with $313.18, which is his total profit for the week. Okay? There's not a lot of money in the toy car and truck business. None. Problem 168 here is pretty straightforward. Given your self-check that you all did yesterday, I think you'll be fine on this one. Just go ahead and pause, do the problem, and then come back to watch to make sure you get the right answers. But this problem right here is just asking you to straight up multiply A times B. So go ahead and do that. And you should get a matrix C. Okay, did your multiplication, all of your rows into all of your columns, and here are the numbers you should have gotten. And then part B is simply asking you to do it backwards. Find B times A, so switching the order. This time we're using the rows of B and multiplying those into the columns of A. Make sure you do that, get your 2 by 2 answer, and then press play. And here you should have gotten 23, 34, 31, and 46. Now, we know that normal multiplication is commutative. That means I could take numbers and multiply them in any order and get the same answer. So like 3 times 9 is 27, but I can switch that order and say that 9 times 3 is also 27. In matrices, you can clearly see via this problem that that's not the case. If I change the order, sometimes I can't multiply, and even if I can still multiply, sometimes I get different number answers. Alright, so part C, you can just realize that that multiplying matrices is not commutative. A and B were totally different matrices, okay? Now you're going to attempt to do what you can in assignment 7.10 on Moodle. All of the problems with systems of equations you can't do right now, so you can skip those. There's quite a few, so you'll probably only be able to do about half of that assignment, the parts that are not the systems. We have to learn that tomorrow. So we'll do that Friday, and then I'll give you some time to do the problems from 7.10 that you didn't get to do today. So don't worry about those ones. If you are not caught up and you don't have 7.7, 7.8, and 7.9 turned in, if you have some time right now, you can take a second to finish those. And then tomorrow we're going to learn our last new thing about matrices, and I will give you some worksheets for homework then, tomorrow when I see you. Get some work done the rest of the hour. I'll see you guys tomorrow.